Guys, just waiting for people to show up. If you want to join the show, the link is in private chat. We'll just wait a few minutes here and we will start. Live chat's open if you want to join the show. The link is in the live chat. Just click on the link. Make sure you have a set of headphones in that. You'll go backstage, and yeah, I'll add you to the show. It's live night Friday. Open lines. Join the show. I put up my invites for our regular guests. Hopefully they'll pop in soon. A little bit late, had some computer problems, but it seems I got that rectified now. Here, I'll put the link again. That's the StreamYard link. If you want to join the show, join the show. There's the link in the private chat. A little bit of computer issues tonight, as usual. We got a big snowstorm going on here in Toronto right now. It's on like blizzard, went up for smoke and shot a lightning went across the sky. So we got thunder, snow right now in Toronto. As the temperature is going crazy, so just bear with me here. I'm gonna plug in the computer. So we're gonna power. Then we'll get the show on the road. If we have to back it up another 15 minutes, maybe we'll just start at 10. I'll keep the line open here. Got my invites out, so hopefully we'll get some regular listeners on. I'll send the invites to your email. Gerard, Bernie, Exotic Propulsion, a few other people. You can join the show at any time. The link is there if you want to join the show. It's open lines tonight. Very easy to set up. Just trying to get the other computer going. Had some issues with that. Had to restart. Then I wanted to do an update. Yada yada. You know how it goes. You shoot for a certain time, it doesn't work out. That's the way it goes. A lot of exciting stuff to talk about. Hopefully, my regulars. All right, Mr. Mikey's here. I'll add him to the stage. Mike, what's going on?
That's
Howdy, howdy.
Testing.
Here. Yeah, I can hear you now.
How's it going, Mike?
Good, how are you? I haven't quite started the show yet. We will do that in about, I say, 15 minutes. I want to get some more people logged in. A little bit of a late start. We got a big snowstorm in Toronto right now, and I've just seen a bolt of lightning go through the sky. We got thunder snow. Figure that one out.
Yeah, actually down here it was cold yesterday and it got really hot today.
Yeah, we're probably getting that temperature change, right? I got
We got to 80 degrees up down here,
80. Cool.
like 35 Celsius.
It's about 0 here. It's about the freezing mark here, so it's kind of unstable right now. I think that's why we're getting the thunder lightning. Big crack of thunder, like midsummer, just a big thunder boomer that shakes the whole sky. Oh, man. Yeah, so yeah, just hang out for a few minutes here and then we'll start the show. Hopefully, we can get Gerald in again. We did
Hey,
a live
Mike,
stream.
you ever see that uh what's his name, Brandon? The last show we did,
Yeah. I
he
talked
brought
with him for about an hour afterwards.
Mhm. He brought
He's
to my attention the forced charge Bedini circuit. You ever seen that thing? That circuit?
Yeah, yeah. I was looking at it.
That's a very nice circuit there. I never saw that before. Never even knew
Yeah,
about that circuit.
yeah. He sent me another link for I think it's BitChute video streaming. Has the whole series of energy from the vacuum. So that was really cool. I watched quite a few videos from that, and yeah, there's some good stuff on there.
That's a very nice circuit. I like how the negative flyback cuts across the drive battery
Yeah,
to
that
get to
thing's
the.
that circuit's over 20 years old.
Yeah, that's new to me.
Over, yeah, it's been it's been out there for 20 years plus.
Seems like a much better circuit than the standard Bedini circuit, if you ask me.
Well, it's basic, right? It's a basic circuit. So that's what as soon as you learn the basic circuit, then you can go forward, right? It's gonna. What's the point if you don't know how it works? The fundamentals.
You suppose that's why Bedini was pushing the SG so hard because it's like easier to understand or something.
Yeah, it's the basic circuit, right? As soon as you learn that, then you can just build off it, right?
I mean, if you look at the forced charge circuit, it's not that much more complicated than the SG circuit.
Yeah, yeah. It's just you build off it, right? You have a platform to start with, and then you just rearrange a couple of diodes and rearrange where the battery gets hooked up. You know.
I saw that new Joaquin Phoenix movie, Napoleon.
Oh right, yeah. How was that?
That's good. I was surprised.
Kind of heard mixed reviews about it.
Well, it's kind of long, maybe boring to most people who are not into history or whatever. But
Yeah,
as far as movie making goes, it was well put together, very well.
yeah. All right, what I'm going to
Good
do is
acting.
I'm just going to zip up for a quick smoke and then we'll start the show together. And then whoever else jumps on with us, then we'll do that.
Gotcha.
All right, sounds good. Um, yeah, okay. I'll be back in a couple minutes. Okay, there, Mike. We'll be starting here very shortly. We'll be starting very soon. Live chat is open. Send out my invites. Send it one more time here, just to make sure. You're back, Mike. We're back. We'll start here in a minute. Just want to send out a few invites again, just in case they didn't get it. Close it again. All right. Okay, we're going to start the show without him. Are you there, Mike? You're there? Okay. Heck with it. We're going to start. Okay, let's do this. Welcome, everyone. It's Friday night, and welcome to the League of Extraordinary Inventors. I'm your host, Mike, from Faraday Research, and live from Florida. We also have Mike, who has a very popular YouTube channel as well. And welcome to the show. It's a snowy night here in Toronto, and we actually had thunder snow. I've seen a bolt of lightning shoot through the sky, make the whole place rumble there for a couple of seconds. So yeah, we got some pretty wacky weather going on here, and I've been doing quite a bit of work on the generator this week, doing a lot of testing on load tests, and trying to fine tune the system, get the implosive inductive reactance um, in the system tuned to that very fine-tuned switching. It is so critical, very, very critical. So yeah, that's what I've been just trying to perfect with the system, make it more reliable, get the highest output as possible. And yeah, so I know, Mike, you did a couple of shows there. You were showing the advanced Bendini circuit, the forced charge circuit, if I'm not correct, mistaken. Maybe you want to
Most
start with
interesting.
that. Maybe you want to start with that circuit. Maybe you can do a screen share and you can kind of show what you're talking about.
Sure. Uh, yeah. I mean, I just find it interesting how that circuit is operating. Let me see which video here.
And the crazy part is, this circuit's not old. This circuit's been out for over 20 years.
It's brand new
And
to me.
yeah, to a lot of people, just a lot of people were not aware of it. And a lot of the stuff we're grabbing off the energy from the vacuum series was, I believe, filmed in 2005, if I'm not mistaken. That's when the actual videos start coming out with Tom Bearden, John Bendini. Who else was there? Fred Friedrich. Who else? A couple other guys. One diagnostics engineer guy, Mark. I'm gonna get his name. Mark Cavendish. I forget his name. He was a diagnostics engineer for NASA, and he started investigating all these over Unity devices. And he actually had the opportunity of testing Floyd Sweet's VTA device, and he was totally dumbfounded by the machine that it put out so much power.
I didn't know
He went,
Cavendish was working with the Floyd Sweet device. Huh?
yeah, he did. Yeah, he got a hold of Bearden, and the deal was with Bearden, if he was gonna hook you up with Floyd Sweet, basically you had to come with an investor or with money.
Yeah.
So he agreed to that, and he helped build quite a few circuits for Floyd Sweet we're talking back 1982. Floyd Sweet died in 89 or 90. So, and after Floyd Sweet died, they said he died of a heart attack. They beg to differ on that. 2 days later, four guys in black suits show up at his door. His wife opens the door, they show a badge, and they go in and basically take all his equipment away, and that was it. It was gone. So, him and a group of guys tried to get together a couple weekends, a month, and try to recreate what Floyd Sweet did. Unfortunately, they were unsuccessful. Now, with what they had available at that time, they didn't have all the pieces of the puzzle, so to speak, to put the device together. But at the time he was doing the video for Energy from the Vacuum, he said probably with the knowledge that we had now, we probably could have went back to that project and maybe got it running. So that's the circuit Mike's been talking about, is the Bandini force charge circuit. Maybe you can kind of go over go over with the um, circuit on how it works and kind of lead us through the circuit.
Um, can you hear me?
Yep, I can hear you fine.
Is my
Yep, go
mouse
ahead.
showing up?
Uh, yeah, I think so. Yeah, yeah, it is. Yeah, yeah, I can see your mouse. Yep.
So
So
this
where are we gonna
forced charge circuit here,
we're gonna start at what, battery one and go from there.
which the run battery.
Yeah, the run battery. Let's start there and just kind of work its way through the diodes and the
So
transistors.
the run battery will charge up all four of these coils.
So
Um,
it's a multi-stranded coil. So it's a bifilar. Well, actually, it's a
yeah, I mean, you can
quadfilar.
ignore all these four and just pretend there's one coil there. I just
Yeah. So basically, what he did was when he made that coil, he took four wires, he twisted them all together. I think he did 1,500 feet, if I'm not mistaken. And he took those four wires and he twisted them all together. So four strands at 1,500 feet, and twisted them all together. And then he takes that one wire that has those four together and he rolls the coil with those four wires straight. So that's how he constructed that coil. If people
sounds like a
knew it.
series circuit.
Well, it's no, it's just four wires twined together, and then he
Oh.
wraps it around the coil, right? So his coils were quite hefty. They were pretty large coils when they were done. Like in my Renegade, mine are 2.5 pounds. I think from what I could see in his videos, they're pushing 4 pounds. So they're quite a hefty coil. So
Let me bring up another share here. Is that the one? Yeah, okay. I have that one.
here's it's not up there. Get back up there again. screen. I've got full screen share going.
So let me erase all this extra stuff here. This one coil is how it's originally designed.
One of them's a trigger coil.
Yeah.
So one of those wires has to be for the trigger, and then he's got a resistor on there. I can't exactly read the number of that resistor, how many ohms it is. I think it's 640 ohms. That's over there on the far left. There's a resistor. It's something ohms. I can't read the number. It's a little small on the screen.
So that's just a standard one without this here. That's just a regular forced charge circuit.
Yeah,
Right
that's a
there.
lot easier to understand. So you're
Oh,
channeling you're basically the for the layman, what you're doing is you're channeling that back EMF through a diode. So the diode channels it in one direction so it can't go backwards. And it's forcing that back EMF into the battery like brute force. That's kind of the gist of that circuit. It's all everything in the circuit is controlled by a diode in the direction that you're forcing the current to flow. So by the diagram you're seeing, there's a diode channeling out of the circuit with a diode. So that back EMF, when it does flash, it can only go to one direction, and that one direction is out. And that is forced into the battery.
right. So
So
green is the back EMF
yeah,
or the back reverse flyback.
yeah. The second you switch it, it flips polarity and shoots out.
So the negative will go out this way here of the flyback, cut across the primary battery into
Yeah,
the
the batteries
ground.
are. If you're looking at the two batteries, you see where your cursor is there, where that ground wire is.
Yeah.
So basically, he's not linked the batteries together at all. Some people could add it as a common ground. That's incorrect. They have to be isolated from each other because the symmetry is not broken. If you try to do that,
Well, they are. The
those
batteries are isolated. You've got the diode.
right, yeah, that's my point. That's what I'm trying to say. The batteries have to be isolated from each other. If they're not, what's going to happen? You're going to get that feedback and it's basically not allowing you to actually do a loop, right? And that's why I came up with that breaking the symmetry, or what Tom Bearden was talking about, breaking the symmetry. So that was the whole point of that. As soon as you break the symmetry, then you can loop it right back into the system. But everybody's hung up on this looping. It makes me loopy. Because looping is really not what you're after. You're after getting the over unity effect. So you have one battery running the system, and you got the second battery receiving the charge. Now, we all know by using that system, you can charge a battery 50 folds faster than you could a standard battery charger because you're charging it with negative energy. So the battery takes that power way faster. So as you're keeping that in mind, it's taking milliwatts or even picowatts of power to run the system. So the system's always producing more power output than it actually takes to actually run it. And that's the whole point of these over unity chargers. Like what I'm working on, the same thing. I'm using a different method, but very, very similar to Bendini's system. But I've added a couple extra components to my circuit that makes mine a little more unique than what he's using. Most people out there want to use transistors and MOSFETs, all these things. I went the other way. I went analog. And the reason for it is the disruptive discharge. The disruptive discharge actually helps initiate the implosive inductive reactance in my coil. That's how my motor works. And because of this, I'm able to run my motor basically on picowatts of power. The input is so minute, but I'm getting way higher potentials coming out of the motor than I'm actually putting into the system to drive it. That's the point of this motor. That's what I'm trying to get across to people
Yeah,
that
this is
are trying
not.
to.
It's not. This is not a closed. It's not a closed loop. It's an open loop.
It has to be an open loop. You can't kill the dipole.
What that means
Now,
is it's looping. It's looping the circuit during the open. The open when the gate is open, right here.
that's right. Yeah, yeah.
Not if it was a closed
There,
loop, the loop would happen when the gate is closed. But in this
right,
case, the loop is happening when the gate is open
right,
and the flyback is occurring.
right. So now, say it was the opposite. Say it was looping while the gate was closed. Well, guess what? You short out your system. That's why he
Right.
designed
That's
the
what this
system
diode
the way
does.
he
It
did.
prevents that.
That's right. Yeah, exactly.
So
That
what
is the
goes
whole
on
point.
here is you charge it forward, with the blue. That's your forward plus your from your battery, and your negative from your battery is right here at the ground side. Connects when the gate closes and charges up the coil like
Yeah,
that. And when the gate closes, and then the gate opens, and in green you have the polarity of flyback polarity happening when the gate is
yeah,
open. When this
yeah,
is open,
exactly. So basically, what he's trying to do is actually using the potential that he's creating from the dipole, but utilizing it
right,
without killing
to
it.
cut across the primary
Right,
and charge it.
exactly.
When he's using the flyback, the
Mm,
negative of the flyback right here, he's
yeah,
using that to cut across the primary right here.
yeah. It's a very
And
ingenious circuit, really. It
using the
is
ground,
actually,
he cuts across the plus and the minus terminal with that high voltage negative.
yeah,
And of course, that high voltage negative has to reach its positive. And it cuts through here, cuts through the battery, through the ground, up the ground to its positive.
right.
Wait, no, sorry, that's when the
No,
gate's
no,
open.
no,
It
no.
can't go that way. I'm
Yeah,
sorry.
exactly. It
It's
stops
going.
at
Let
point.
me rewrite that. It's going this way. Sorry,
Yeah,
through the
yeah,
battery, down the ground, up
and
the
that's it.
ground,
It's dead.
and
Well,
the positive. Sorry, the positive cuts across here to meet
right.
right here. Right, here
Yeah,
is where they meet. Right there
yeah,
is where the plus and the minus meet.
yeah. It's just the way he's channeling the power in the system.
That would
Yeah.
explain why this diode always gets hot,
Oh yeah, it will. Yeah, for sure.
or whatever. Hot, I guess, when you're not at the right frequency, maybe.
Yeah,
It should not get hot when you're running at a good frequency. It shouldn't get hot unless there's some kind of a back you're forward. I don't know. There's no reason for it to get hot here if it's negative.
well, yeah,
Versus,
exactly. Yeah, the negative energy. If there's negative energy going through that diode, it should not do that at all. That's the whole point of it.
which
Now
was, I think it was the resistor that always got hot, if I remember correctly.
yeah, the transistor. Yeah, you could fry those suckers very easily, and he's blown up many.
Yeah,
Yeah,
if you don't have it insulated with from the heatsink.
yeah,
So that's interesting. It channels the negative flyback through the primary
yeah.
battery,
The
giving it
problem,
flow charge.
right? The only problem with that circuit is not rock solid. If something fails, one of those diodes fail, your transistor goes bye bye.
Well,
And he's blown many. He says he's fried many transistors doing it.
you can always turn your voltage down on your primary.
Yeah, but the kickback on that always seems to fry those circuits. They just can't handle it.
Sorry, the
So,
diode?
well, no, the transistor can't handle it. Sometimes I've heard them actually even frying the gate too. If you don't get that right ohms resistance on the trigger, you can fry the gate. And most transistors, they trigger between 2 and 5 volts. So you got to make sure at all times you're only getting 2 to 5 volts going through that trigger. Otherwise, you're going to fry the gate, and that's it. Your transistor's toast. So yeah, irregardless, it's an interesting circuit. It's genius how he channeled the flyback through the system without shorting out and killing the dipole in the process, and keep the motor running in sync, right? So, but I liked how he expanded off it when he did the energy from the vacuum series. He's talking about the Tesla one wire system, and that's what I'm using in my Renegade system right now. Is the Tesla one wire system. So I can loop the motor back. I put it through uh, step up transformer, and then from the transformer, I put it to a full wave bridge rectifier. From the full wave bridge rectifier, I put it into 60 volt, 12,000 microfarad capacitor, and then I put it through one more bridge rectifier, and then it goes to whatever mode I choose. And if I choose to move it back to the battery, I can do so without shorting the motor. So, a very cool little circuit. And I've got the schematic on my Patreon. If you go to my Faraday research in the description, one of my videos, I got my link for the PayPal and also the Patreon. And yeah, so
I look forward to replicating it, see how that primary battery holds charge like that, which it should, looking at the circuit.
mm,
Just looking at the circuit, it tells me that the primary battery doesn't have much of an opportunity to lose charge.
that's right, because you're doing super fast switching. And that's called the current free potential. So if you listen to one of the lectures from Dan Winter, he talks with a lady named Elizabeth Donovan, and she's an electrical engineer. And her and her husband Bob, they've been working on these systems for years, and they pretty much worked with every single generator in the U.S. that the Bedini motors and the Adams motors and all that, and he pretty much knows how all those systems work right to a T, and have a scientific explanation of what the phenomena is in the motor that makes it over unity. So, in case of my motor that I've been developing over the last 5 years, it's implosive inductive reactance. So the implosion is the field in the coil collapsing, and the reactance of the flyback hitting the transducers, and that I still really don't understand exactly what's happening when that flyback hits those transducers. It's doing something I don't know. I just can't put my finger on it. It's an interesting phenomenon. That's all I gotta say.
Mike, can you
But
describe the connection again to the transducers and your circuit?
okay, okay,
How it's
so you got your you got your standard coils. So wrap, I recommend going 24 gauge wire, at least 1 pound or better
but
to
like
your
the
set.
transducers are two of them in parallel, right?
They're in parallel, yes.
And
Two of
from
them.
there, let's say you got a parallel circuit, and then how does that connect to the switching circuit?
Well, it connects directly to the coil. They run together. So you got the
Parallel to the
coil.
coil or
Yep.
series to the coil?
No, no. Actually, I've done it in series as well. It still works, but I prefer to hook them up in parallel.
Parallel. And then you
Yeah,
oscillate the coil from there.
and then I oscillate the coil. So the inductive
Which would oscillate
reactance.
which would also oscillate the transducers.
Yeah, right at the same time. So there's like a kind of a pedaling that's going on with the
It's
inductive
sort of
reactance.
it's sort of like you're oscillating an inductor and a capacitor together because the
Maybe.
transducer is kind of like a capacitor plates.
Yeah, like when you put your fingers on them, it gives you a good little vibration on your finger. I'm talking like electrical discharge. So you actually get electrocuted a bit when you touch these transducers. I'm using barium titanate, which is the best that I have found. They're readily available on Amazon. Their low wafers is about an inch and a half in
I'd say that
diameter.
why you're getting better charge with those transducers is because the transducer has surface area.
Yeah, that's what it is. And it's like electrostatic
It has
in
more
nature.
surface area than the coil does,
Yeah,
I
it's like
think.
electrostatic in nature. It's really cool. Very cool. So yeah, it's very, very interesting phenomenon, to say the
And
least.
keeping in mind that the positive and the negative of the source has to, has to go into the coil from both directions. And when it flies back out of the coil, it has to fly out of the coil in both directions. Whatever
Right.
that flyback goes, it has to meet whatever it's meeting in both directions. And if that's the transducer,
Yep.
so you have a pressure wave of
Yeah. Yeah.
from
It's like a
both
shock wave.
negative and positive hitting both sides
Yeah.
of the transducer
Yeah. It's like a negative and
simultaneous.
positive shock. Yeah. Shock wave. That's the best way I could describe it.
It's like doing this, you know,
Yeah. Yeah. And
without actually touching them.
yeah. And I've actually hooked it up and disconnected it while it was running, and there's like a 40 or 50% increase in power. Like it's like flipping a switch, like the turbo boost. It's like a turbo boost for your coil. Flyback.
Do you ever try running it without a coil, just oscillating
Oh
the
yeah.
transducer by itself?
No, no, I never tried just a transducer. I don't know if that would, I don't know if that would work.
I mean, it still has surface area.
Right.
It's,
Yeah,
and it
you're right.
has inductance to it, no?
Yeah, it does. You know what? I can't freaking try. Well, see, the problem is,
Does the transducer have impedance to it? Is it resistance? Does it have a resistance value? Do
oh yeah, for sure.
you know what it is? Or
Offhand, I don't know. No, there is resistance on it for sure, but it's barium titanate, so there is a reactive element, almost like Casimir type effect, electrostatic, very much electrostatic in nature, because you could use those transducers for the jewelry cleaners. You can put your jewelry in there and they use the ultrasonic frequencies to clean this.
I thought that was an instrument pickup also.
No, no, no. The instrument pickups, they're made for audio. There's specific transducers for specific parts, right? For specific application.
Mm.
There are transducers for guitar pickups. There's ones for like microphones. There's ones for making mist or the steam fogging machines. There's a whole bunch of different types, but all have kind of their own unique characteristics. So the barium titanate, that's what Norman Rutan was using back in the early 90s with his MRA device. And that's when he went to go file the patent. And the government seized it up because it was over Unity. And they said it was going into the drawer and you'll never see the light of day. So,
Sounds like a
so
violation of your First Amendment free speech.
Well, it's basically what you're doing is you're taking your invention to a gatekeeper, and they'll say, "Okay, it's our spy," and you can't do a thing about it.
Well,
So,
circuitry is a form of speech. So is programming and software. It's all free speech.
it's like information. You know, if you have certain amount of information, they'll take that away from you and they'll put a gag order on you. You know what I mean? Or yeah, it's
They
you
violate your
know,
First Amendment, right? Huh? Just like that.
yeah. So basically, what you learn from this is don't get a patent, open
Yeah.
source it. If you open source it, nobody can go after you. Nobody can. It's like saying, "Oh, you've invented air. You're not allowed to breathe."
The only reason to get a patent is if you're trying to make money, I guess.
Well, that's
But
where a lot of these inventors in the past failed because they're thinking about how much money they're going to make and didn't realize that, you know what, the patent office isn't in your best interest. They're only worried about their best interest. And your best interest doesn't converse with their best interest, so they seize it on you. So, yeah, it's a crock. It's a totally rigged system. You know, it doesn't even matter what country you live in. Like I live in Canada, you're in the U.S. Doesn't matter. It's all the same. They all follow the same kind of rules. Anything that is disruptive to their status quo, you know. But it's going to come a day where you know what, shit's going to hit the fan. We're going to get one very good solar flare, which we did back in December. We had an X5 flare, and guess what? Your power grid's going to go bye bye. And guess what? Three-quarters of the U.S. population will die within the first 4 months.
it'd be nice if someone can come up with a free energy heating device or a free energy cooling device. Stop all this people from freezing in the winter or burning up in the
Well,
summer.
you know what? There's a guy working on. I'm trying to remember his name. Jeremiah, I believe his name is. He's in California. He's working on the Tesla turbine, and he's got a model right now that's working so good, and he's miniaturized it that you could actually fit it on a kitchen table, and it's putting out, I believe, 7 kilowatts of power. I think it was 7 kilowatts it's putting out.
He's powering it with
So
water.
steam.
Hmm.
Basically, one side's steam and the other side's freezing cold. You got the pressure differential. You transfer that steam through the turbine to the cold side. Because the cold is less dense, it sucks the heat out of the hot side through the turbine and into the cold side. And then he circles it around, heats it up again, and goes back in the loop. So it's a closed loop system. As long as
Hmm.
there's a temperature differential between the two sides and the turbine's in the middle. So cool. Hot on one side, cold on the other, the turbine's in the middle. And it's all valve control. He has all the valve controls and gauges. So you can monitor the pressure. So as long as that pressure is up on the hot side and the pressure is low on the cold side, that thing will continue to pump out power. And it was actually Tesla's favorite invention he made. Out of
So
all
wait,
the
the Tesla turbine was operating in the same principles as a Stirling engine,
basically, yeah, but
without a diaphragm, I guess.
yeah, yeah, he was using the turbine and steam, and the other side was cold. So
I
yeah,
still think the
so
Stirling engine is more efficient though because it has the diaphragm.
well, it's making a comeback. There are a lot of companies, I believe, in Britain and Ireland, and I think there's a company, if I'm not mistaken, out in BC or Vancouver. I forget where, but they're working on some new concepts. I know NASA's been working on the Stirling engine for about 20 years now. They had a model running for 14 years non-stop. Did not break down. No, like it's only got basically one piston that goes up and down, and it's free running. Ran for 14 years nonstop with almost no wear. So systems like that, they're going to put on like long distance satellites, you know, for space exploration. Eventually you're going to need a power system on the moon or a power system on Mars. Stirling engine can basically run off any fuel source that can make heat. Doesn't matter what it is, wood, garbage, oil.
Well, its primary fuel source is supposed to be the differential between cold and hot. You don't really need to create anything. Just need to
Well,
find a
you
hot
have this.
surface and a cold surface that already
Yeah,
exists. Don't
right.
even waste fuel.
Yes,
Yeah.
exactly. That's why it's kind of making a comeback, and it's over 200-year-old invention. So, Stirling
If I
engine.
were to make a Stirling engine, I would make a big one and bury half of the heat sink under the ground where it's colder, and then
Yeah,
it should run right there
yeah, geothermal. Yep. But
and use the
those,
heat from the air.
yeah, certain geographical locations will make a system like that run better because either the area is volcanic in nature. Well, obviously, there we go. You've got a heat source that will last a very, very long time. So, exactly. So, yeah, there are systems out there. It's just a matter of people actually, you know, working on the tech and actually doing something with it, right? So, it's just a matter of time, right? Where things are going to break
Need some
down
more
and
inventors.
well, it's not that there's not enough inventors. There's plenty of inventors. It's just they gotta loosen up the noose. You know what I mean? Like they gotta
Well, I
start
think
letting things.
all these inventors are trying to get rich. That's the problem. That's what's the stifling
Well,
problem.
that's
Everything.
yeah, that's where a lot of them went wrong, and some of them actually paid with their life, right? When you play with these guys, you're playing with a group of guys that are hell bent on keeping the control, right? I think that's the thing. That big thing is the control. If you control the world's energy, you control the world. That's it. Period.
Machine
The
Head said
problem
he's got it
is
running.
which one? What has he got running?
Says he's got it running. What's that Machine Head? The Bedini system? He says I got it running.
Mm,
I think he's talking about the pulse motor.
maybe.
I know the
There's so
feeling when
many
you
different.
first get your first pulse motor running. It's like an
Yeah, it's a
achievement.
good feeling. Yeah, it is. It's just kind of neat to actually watch it, right? And like, cool. You know what I mean? It's like, now,
I
where
got
do I go from
frustrated.
here?
I got frustrated with my first build with that Bedini. I wasn't running, and what's going on? I had
You
to
know
add
what? The
more
first mo
magnets.
No, the crazy part was I tried to copy the Bedini circuit in the beginning, but I was very confused by it. So I came up with a different trigger system, and that trigger system I'm still using today. Right from the very beginning, I just thought, hey, let's use an automotive relay switch. So I got that, and I was using a regular magnetic reed switch, and I got it going on the first try. I'm like, okay, this is cool. Then I started learning about flyback, and I destroyed the first reed switch, then I destroyed the second reed switch, third, fourth, fifth, and
Yeah, right.
next thing I know, I got a whole graveyard of reed switches. And I go, okay, this is not going too good.
I got a
So,
graveyard of transistors.
yeah, so, and those reed switches are like 12 bucks a pop, right? So I said, okay, we got to come up with something else. And right around that same time, just about 2013, yeah, about 2013, I was building 3D printers, and I was using a proximity sensor for bed leveling. And I'm looking at it and I go, how could I install that on my motor? And I read up on the wire diagram for the proximity sensor, and I go, oh yeah, this is totally doable. And I hooked it up and fired up the first time. And the best part about it is now that I was able to isolate the trigger mechanism for the relay switch without frying the crap out of it. So I was like, woohoo! And that was the beginning of my circuit. So it
Your
wasn't,
trigger, your trigger was getting fried, or your read was getting fried. So you needed the
see,
proximity sensor to isolate your read. Okay.
okay, see, at that time I wasn't using the relay
Transistors.
switch. I was using the relay switch, but what I was doing, I was feeding off the same power source. So when the flyback came up, it went down the channel of my read switch, and that's when I was frying it. So when I hooked up the flyback, uh, I was now able to isolate it.
So
We did
wait,
another,
you isolated the flyback with the proximity sensor.
yeah. It's well the way the relay switches are made now. I'm gonna add another guy to here. Show Big Logan. Welcome to the show.
Hey,
How's it going?
Welcome.
Where are you
Logan,
from?
Whitefish, Montana.
Oh, you're in Montana.
Yeah,
Yeah, Mike is in Florida. I'm in Toronto, and
or
it's snowing like
my,
crazy.
I had a rental car from Florida, but I had to get my brakes right when it froze. It froze. The brakes in the windshield cracked in the car. Like as soon as up, it was 20 below outside and like 80 inside. I immediately turned around. They're like, "Oh, gee." I was like, "Yeah, I already got messed with Florida plates on the coldest day." But anyways, see, I got
Right. Everybody's
cam.
a drug
So,
dealer if you're from Florida, right? Or Texas.
oh,
Uh,
Toronto's getting bad now for auto theft. Oh my God,
I did
you
this
guys have
before. I can either switch my camera or find a way to see what we
So what are
got.
you working on? Oh, you're working on the Sterling engine. Right on.
This was
Yeah.
pumping this Sterling engine out,
Oh, you got the Sterling engine.
Yeah,
and
cool.
DSC. They make the Sterling engine every year. It's not hooked
Mike
up.
maximizes speed.
The
Yeah.
flywheel is for looks, and it's a little weighty. I got to get it hot, and this is the chamber, and the cold air chamber. I don't know. Maybe shut the heater off.
Oops.
Uh,
Yes.
switch my camera screen. At least
Uh,
So
camera.
machine head, you're a machinist.
Yeah, yeah.
That's cool.
I'm always excited when I'm on. What did I do with the camera? Oh, it didn't switch over.
guys, you guys can chat for a minute here. I'm gonna scoot up for a quick smoke. I'll be right back.
My shots
That's
was a little frozen, so I got it redoing it all. But I don't know if you guys could see. Should we fire it up? It's all
good.
over columns. It's like we did a whole thing where we're like, no, we want this flywheel. It's a little weighty. It, she's making a little racket. I have to watch this. See the chamber in there. See her right in the center right now is a pin. If
Yeah.
anything, it's not my fault. It's that pin. But okay, let's see. Sure. I don't know how hot to get it yet. I might set you guys down. Turn it down a little bit.
Chris, it's all about the diaphragm that holds
Yeah,
the air
it had
inside
some,
the Stirling
I think.
engine. So whatever you use to heat up the air, it's a piece of metal, and that's where the Fresnel lens would focus onto the
And
heat
then
sink of that.
piston, it's hollow inside there.
Right. It's just a heat sink to gather the heat or the temperature.
So I'm thinking shutting the heater off helps. I gotta wing it. I wanted a little lighter one, but the whole class did this project, and then at the last minute, I was the second oldest student, so I had to help get it going. It's been going about, how long they say that one? 14 to 16 years.
Is that the one that the space program made or something like that?
Yeah, we made stuff for them, that too. That was all the space stuff is all college projects.
I was
Like,
telling
well,
Mike, you know,
it's
in
all
theory, you know,
projects. She, well, it stops sometimes just dead. I bet it takes a lot of energy.
well, if you're, you know, if you scale up the
You
Stirling
know it.
engine and you scale up the diaphragm size and the heat sink size, once you get to a certain, you know, dimensions, it can run off the temperature of the ambient weather. You don't need to provide a flame. It won't spin fast, but it will move with a lot of torque.
That's a lot of weight, not, yeah. So, I don't know. Can you guys see good? I can hear you. I
Yeah.
got the. I promise, but I don't know when it was, and even he was out in Bernie's, and then before everyone pulls everyone's leg, sometimes I'm like, oh, I wrote a Stirling engine somewhere. But now I'm redoing it. I got a little area for my daughter, so I could get my little office back.
I mean, if I'm not mistaken, there's two chambers in there, right? The hot and cold side.
Yep, I got, and in the middle is a hollow piston. It's like custom machined. I have a few. I might need to do some work on this thing. I've been meaning to. I got another one that's
The key
not.
to the machine is in the diaphragm, in the air chamber there.
That was the. I had to use quite a powerful lathe to get it in one shot, to get it in 5 minutes in a modern time. For that, I might have got it too hot. I don't know.
I was telling Mike, you know, like if you had a Stirling engine, like let's say the size of a car, it would run just because the chamber that holds the temperature is so big that it would capture the ambient temperature of the Earth's air. And if you buried the other half of the chamber, the cold half under the ground, it would run just like that with no fire or needing to add any type of external heat to it. It would run just like that. It would run slow, but it would have a lot of torque.
Yeah. Run a generator for sure, no problem.
There's another setting on here. It'll run a generator and a flywheel. I should get.
So the Stirling engine can run off of ambient temperature. You don't actually have to heat it up.
Yeah, as long as the temperature differentials within a certain ratio, from what I understand.
Right, but you can't reach those ratios with a miniature version. You have to build a much bigger diaphragm, much bigger chamber.
There's a guy, I believe in Australia. he's got like this farm, and he's got several of these machines, like on a very large scale. It's quite impressive. There's quite a few guys out there working on this stuff in Australia that are just mind blowing. A lot of them are, guys that work in agriculture, right?
People don't know it. The Stirling engine is probably the most efficient uh, non-combustion or whatever it's engine or whatever. It's an engine. It's not a electrical device. It's an engine, and it's the most efficient engine I think that ever existed, that will ever exist.
Now, I've seen guys run these on these parabolic mirrors. Uh, I've seen them run.
Yeah, those parabolic mirrors are just assisting in the temperature differential.
You know, I'm
That's
focusing it on like one central area. I'm hoping that maybe you guys are right. I could get it to run on this candle maybe. But it's
yeah, like you can run it just on
its RPM's
alcohol.
about 700. My guess 69. I'll just guess that. That's some number machine I got machining.
Yeah,
Heavy duty 50K per cat Haas mill.
yeah,
Like if the
Yeah.
cold side of the chamber was in the water and the hot side of the chamber was in the air, and the diaphragm was big enough, it would run without anything else.
I work on a water jet, so I can make a lot of parts in the water jet.
We try to machine that stuff sometimes. That's what happens. Oh sheesh.
That's good to have a lathe around, man, and know how to use it.
Yeah, I have in my personal shop smaller
Yeah,
versions of everything.
You
and it
don't have
still
to
works.
scrounge around the internet looking for parts. You can just go ahead and make exactly what you need.
Oh yeah.
Like parabolic mirrors. I've seen a few guys working with them. They generate a massive amount of heat, even when the sun is not like at peak. You know what I mean? It's incredible how fast they heat up is incredible too. It's like instantaneous.
See,
I don't know.
Collins.
I saw this video on YouTube that says that the Egyptians were using parabolic lenses to melt granite,
Oh, gee. Yeah. Oh, it would.
and they had a portable two-man on wheels parabolic lens that they can move around to not only to melt granite but actually cut stone too with it.
I don't know. I like the nostalgia of Sterling engine. It's a 200-year-old
Look how fast
plus.
that thing is running. Are you still adding
Oh,
heat to it?
Yeah, it's being a hog. It's like I said, it's been running for 16 years, but rare occasions. But I haven't showed it off for a long time. I promised Bernie, but I promised Mike on Bernie's, and I never got to it because I just I'm not supposed to mess around too much with stuff. He said everyone thinks you try to make money, and I'm not supposed to make any money, I guess. Yeah, but we're trying to think. I got a homestead, so it's something like this. If it was bigger, I'm almost thinking water pump, and even
yep.
just to have kind
Yeah, well,
of thing,
irrigation for water pump for a well or
because
irrigation
I'm
for a farm.
at the border up there.
A nice
It's
build, Machine Head.
it's why I've been making all my videos. Kind of there's all these little inlets on the outside of Glacier Park that go into Canada, and
Yeah,
I've been showing a bunch of stuff like that. I'm actually gonna put a video out one of the spots too where we go in snowmobiling. and then hopefully we're going to be able to go in on snowmobiles on Monday.
Yeah. We're getting hit with the
It's been a
storm
weird,
right now.
weird
I hate
winter.
to say this, but I think the Stirling engine is more efficient than an electromagnet.
If you had wood to burn under it, didn't you had some stuff buried and probably infrastructure. We added the stuff for it. It's just not set up for it now. It's right in there. It's barely
Like even if you live in a seismic, volcanic area, you can geothermal, the heat into one of those engines. I'm sure you can
if I
power it.
start seeing anything in there that could tell me to slow it down maybe.
That's a really nice build. It's definitely a nice build. I like it. Is that brass? You made it with brass?
See, if you take that heat chamber, that diaphragm that holds the hot air that he made there, and you scale that part up, once you get to a certain size, it won't require any additional heat. It'll capture the ambient temperature, and it will be enough to give it spin with a tremendous amount of torque.
It's it's
Very slow RPM, but it'll be like one of those oil rig things running a bit slow.
could put
with
this
rod
on a
speed. I heard those things that move up and down for the oil pumping. I heard those are free energy. Did you know that?
I
Really?
wouldn't I've been in some, they're not hooked up to anything.
Isn't that weird?
So,
But those
so
things that
how's
move
it?
up and down for the oil,
So how's it? So how's that work?
I don't know, but I heard they're free energy devices. It's just like one of those under the radar things that people don't know.
Depends
Is
on
there
the
like heat? Is there like
It's
heat?
a
Heat
pendulum
coming out?
pump. It's a pendulum type pump system.
Now, is
And
it because of
it's an over
the
unity. It's an
gas
over
and
unity
heat?
device. It's definitely over unity. I'm sure they're giving it a little bit of power, but the amount of torque it's giving out compared to the amount of torque they're giving it to keep it spinning is, you know what I'm
Yeah.
saying?
there's a there's a valve in like a closet kind of thing, and you get a confined space permit to go in, machine in the valve.
I don't know what those things are called either, but
What was that? There's
there's a name for them. Oil pendulums or whatever.
Well, it's for pumping the oil up, right? So
Yeah, it
there must
sucks the
be
oil
some.
up, but it's. I
Yeah.
heard that's an over unity device from I think it was
Well,
Magnetis.
it's probably the pressure of the oil under the ground is actually
Or maybe that,
forcing
yeah.
that.
Once you get the oil, once you tap into that pressure down below, it just keeps
Yeah, it's
running
like
until that pressure below is over.
I need to
yeah,
cut out
That
the way,
might be the case. Yeah.
cut all the
Nonetheless, it's still an over unity device if it's able to tap into the pressure and stabilize the oil pressure like that.
another one's the old watt hour meter on the side of the house. The old ones with the spinning disc in it. Apparently, that was an over unity device that Tesla made.
Yeah, I think I heard that once too. But you're talking about the
Yep,
meter disc.
yep,
Tesla
Faraday.
designed that.
Yep, that's a Tesla's Faraday disc watt hour meter.
Oh, but he didn't design it to measure power usage. He designed it for something else, I guess.
Well, it was originally designed to do the watt meter running, but the way it was designed, all you needed was a seed power going in it, basically 120 volts at 1 amp, and it created the induction in the coils inside the meter itself, and actually created about 80 amps. Back in those days, that's all they needed was 80 amps, actually less. They didn't have, the amount of appliances that we have today. So the actual major power generation was actually done on the side of the house. As soon as you put a load on it, the thing would slow up and then it would start spinning backwards. That's when the coils start pumping the current. And they used to rumble too. They used to make a big vibration. So I was investigating that one for a little while. I haven't actually got my hands on one. They're hard to get here because it's all smart meter now, right? Which I really hate. But I do remember them as a kid. I remember hear them rumbling, when they went under heavy load if you had an AC running or whatever. But
Doesn't look like it. It's a little heavy.
I got a small Sterling engine with a demonstrator. It works. It's the Type 1 beta.
I like the one I could get. I should get that one and show it. It's like it looks like a trampoline. All it is a diaphragm. It looks kind of like a UFO.
Yeah,
It's got
yeah,
wings, and
that's
it
the low pressure
uh,
one.
So someone's got to make a Stirling engine power plant. It's just got to happen, dude.
I think it's
Yeah.
going to. I think there's some guys working on that now.
At least they put a Stirling engine at one of these substations. You know?
I
Yeah,
wonder
the
if
other
they
ones.
have something to do with what were they what was the big thing? Ventilators. Like ventilator could run a system somehow. Sort of like if you're off grid and as a vehicle you'd want a fire truck because it can do lots of things. So I'm wondering about those ventilators too when they were wanting.
The type of systems we're talking about here could keep America from being dependent on for energy on any type of emergency situations. We'd be like pretty much invulnerable to, impenetrable to
Well, you know
energy
what?
emergencies.
Well, if you're in an emergency situation, if you have to burn something to survive, I think you're going to do it. You know what I mean? You're going to use what's available
I
at
mean,
that time.
not just winters and summers, but medical emergencies. You need power. You
Yeah,
know,
exactly. But we're talking, say, in an instant that we have a major solar flare like we did last month, that could potentially take up the power grid.
I'm just
Our
saying, as the power grid is right now, as the American system, that is right
Yeah, it's
now,
not very redundant.
it's not very well protected because
No,
we're not using systems that are self-reliant.
there's 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 no plan B.
Our
That's
system is not durable. It's not self-reliant. It's not durable.
like back in 2012, there was a major X flare hit northern Quebec and took out a whole town's power grid. They were out of power for 6 weeks.
They put in some. They did some stuff. The grid did some stuff for these surges, the solar flares. They added these little things that go on the
Yeah,
lines in between.
they're like a lightning arrestor type thing.
Yeah, I don't know. I mean, those have never been tested yet. There's, against a real solar flare, as far as I
Exactly.
know. But
Exactly.
they're making
So
some
we're
kind of preparations. But that's not going to keep the power on per se. If the solar EMP would damage the
well,
grid, it's not going to keep the power on. It's just going to keep the grid from being damaged too badly to the point where they can get the
right.
power on in a reasonable amount of
That's
time.
right. That's right.
I
I
still
think
think that's
that's
not good enough. It's not good enough.
no, it isn't. They should have been working on this stuff
They
50
could do better
years
than
ago.
that. It's a lot easier, capacitor banks, and there's so many things they can do.
The Carrington event, that was
I
like
mean,
18.
think about the capacitor bank. If there's a solar EMP, the capacitor bank will suck it all in. You won't have any incident at all. The grid will be fine. You know,
We definitely have the
if you have a
technology
big
to.
enough capacitor bank on the grid, and there's a EMP, you're just going to charge up your system
Yeah,
for the next
but
year.
I think what the point
Who's
is
going to need
that
nuclear if you have a
Battery,
system like that?
low battery.
my, you know my point is, you know we have the technology to fix it. Okay, it's just that the politicians are not feeding the money in the right direction to get this stuff fixed or upgraded.
If they added
And
capacitor banks to the whole grid during the day when the sun is radiating, it would charge the grid up. because of all that radiation. It's already doing it now with the grid. All the solar radiation, it's already harmful to the grid during the day. That's why you see the voltage goes up during the day on the grid a little bit. That's not the
Yeah.
that's not the grid voltage. That's the sun doing that.
Yep.
Yeah.
I'm pretty sure.
And at night, the grid voltage drops because the sun is not, radiating the grid lines everywhere.
Hmm.
Yeah, for
Like
radiation.
even even picking up radiant energy. There's a company in Florida, I believe, the Ionic Research Laboratory, and they got these masts. They got four masts that I think they're about 30 or 40 meters tall, and they're producing about 1.3 kilowatts of static potential just from a loop antenna, and they're charging giant capacitor banks in the lab, and they're making usable power with it. And this is all atmospheric energy, so there is a lot of alternatives. Just have to put some money into it, and you know
The one
get it
thing
tested.
Elon was right about was building capacitor banks to put onto the grid. Out of all the things he's thought of, I think
Yeah,
that's probably the best thing he's thought of.
sure, it's power storage, right? You always want to store power ahead. So
Yeah,
That would
I
end the end
making
of
a
the
bunch
problems with the
for
grid.
a guy, and that's what he bought. That's what he made. He made a battery like that with all this money he made, and then it went away.
Yeah, whatever happened to that, you know, that thing with the batteries that Elon wanted to add to it was capacitors really, not batteries. He wanted to give the grid capacitors, and he was building a what do you call the power wall? He called it
I
the
don't.
power wall.
Did
yeah,
maybe they
power
use
wallet.
South Korea in Korea instead or something? I don't know.
Well, it was
Everyone,
taking off a little bit in this country. People were like, "Yeah, the power wall, get it for your house." Don't you remember that a couple years ago?
it seems like
Yeah,
all the different civilizations have to share over time. Ooh, who gets to use?
yeah. It depends on your geographical location. If you live in a desert, use solar. It just makes sense. You know, if you live in an area where there's a lot of volcanism, okay, geothermal. It's a no-brainer. You know what I mean? Like every geographical location will have a system that best suits that location. So, and they're starting to do it. They just got to emphasize more on the making more power plants, making bigger, more power output. Same thing in windy cities. Okay, well then use the new up to date those, wind farms. Not those giant blades. There's ones that are way smaller that put out
Gonna try it
a
again.
lot of power. Like we have several. Well, we got two big windmill farms in Ontario where I live. I've seen both of them, and these freaking things are huge. Like the blades are like 200 feet long each. Like they're just massive. And I'm thinking to myself, why are they building them so damn big? Like build them smaller. And there's new blade designs that are way more efficient than using like a propeller design. Like that's old archaic technology that I've seen some guys build some pretty amazing windmills using a different type of blade design that takes a lot less space. It's not dangerous for birds. The birds aren't going to get killed by the blades.
Even
You know.
the vertical turbines are killing the
Well,
birds.
yeah, even the vertical ones. Yeah, I've seen some, but they're not as big. Like they're a lot smaller.
When they're
They're
spinning
not as
fast.
yeah, but yeah, I think the big blade ones, the propeller ones, I think they're a lot more dangerous because you get too big of a gust of wind, and those things can fail.
The maintenance overhead for those are too,
Oh
you know, it's a debt solution. That's all. It's not even a debt solution. It's a debt creator.
yeah,
It's a lot of maintenance on those devices.
yeah. And I think they're, from what I heard, they're only good for 20 years and have to be replaced.
It's more cheaper to create power locally with smaller devices at the
That's right.
source, at the site,
Yeah,
not
yeah.
transmitting it all
Decent,
this way, you know. All
like
this
I've been
transmission
preaching,
is where the cost comes in.
like I've been preaching all along. It's got to be decentralized. If you do a decentralized
Right.
power system, you got way more redundancy in the system. You know, blackouts will be very, very isolated. You know, and
Right, because
you
everybody
can
has their
send.
own little generator right at their house. Why do you
That's
need to
that's right.
transmit anything?
That's right. That's exactly right.
You transmit it from your backyard into your house, just like you would do with a
Well, but
regular gasoline generator.
yeah, like I like to make a system that's going to be no bigger than an air conditioning unit that sits outside your house right now. And if I can make a unit that big that would power your house, definitely, that's
A
my
lot,
ultimate goal.
a lot of these people that like to invest in energy technologies of the future they're getting they're getting uh, you know, their eyes are being driven towards nuclear batteries and stuff like that.
Yeah, there's
Which,
another one that's coming on the
which
horizon now that I just seen the conference for. They're in Switzerland. They're creating a thorium reactor.
yeah, the miniature
So,
little nuclear batteries and stuff,
yeah,
thorium
so nuclear
batteries.
battery. I think the next big thing that's being worked on right now. I think for any energy system is the energy storage. That's a very big critical component of this.
Yeah, but these
So I think
thorium
the next.
batteries, they actually put out power,
Oh yeah, oh
they're
yeah, they put
radiating.
out a lot of power,
I
and
think it's
they're a lot
ridiculous. I
safer.
think yeah, it's a great solution to energy, you know, problems. But you know, what kind of radiation is thorium is probably the safest form of radiation you can mess with. But
That's right.
you mess with any kind of radiation, no matter how safe it may be. Why mess
They're
with
just
nuclear radiation when you can have a more less of a nuclear radiation than
it's
I
just
don't know.
trying to.
Thorium is a nuclear radiation. I don't think it's safe at all.
No, thorium apparently is a lot less radioactive properties than regular fission, but
But
nobody has
nonetheless,
been.
it's radioactive, and to have something radioactive that close to your
Yeah,
house is.
they're just trying to reinvent the wheel. You know what I mean? They already got that type of thing. Now they're trying to go in a different direction.
I'm just
But
saying these
it's not.
thorium batteries and these nuclear batteries is just. I think it's all propaganda.
Yeah, could be. Could very well be.
I think it's ridiculous. I think it's nuclear propaganda to push nuclear technology, which
Hmm.
is I'm talking about nuclear as in harmful nuclear radiations, not the kind of radiation we're dealing with.
Yeah,
It's all radiation. One is uh, nuclear thorium radiation is very saturated, type of radiation.
yeah,
I don't think it's safe. That's all I'm saying. No matter how
yeah.
safe they say it is.
Personally, I've never been a
They
big
they say
fan of
these
nuclear.
engines weren't safe either because they had a
What?
tendency to sometimes self-destruct, and then the parts, if they're the bigger they are, the farther they fly.
Yeah, you got the corrosion factor, the decay factor.
They were
Devices that don't have decay to them are available, for the same purpose of creating
they were
It's
energy.
also,
they I think they were. Hey, kitties, you might want to watch out. I got an audience.
I think, the problem too is with these systems, they got a very, very large price tag. Very large price tag. They
And
always
what?
go for the system. The systems are so expensive. How many billions of dollars they put into this stuff.
What, nuclear reactors and stuff? Yeah.
Yeah, it's just mind-boggling.
Well, that's how governments operate. They need to make a project that costs a lot of money to get the money, like
Yeah,
NASA. I mean, an expensive project. How are
well,
you going to get the money if it's not expensive? You got to get people to
it's just
believe the project is
it's
expensive.
it's it's another way of uh, extorting money from the tax system. It gives them a reason. Oh, we need $25 billion to build this new reactor. If we really need it, the power grid needs to be upgraded. But it's going to cost $25 billion of the taxpayers' money. Thank you very much. Have a nice day. So, and,
I mean,
and
the truth of the day is nuclear power is keeping us from keeping the lights on. Pretty much.
yeah, it is, but it always comes with a cost, you know?
Right. And what I'm saying is it's not the only option. It never was.
Right. So the thing is, you know, I I just can't believe that nobody can come up with a system that will make a safe system, a very a reliance system, and something that will be cost effective. We have the technology to do this now. We had it 20 years ago, but it's the bureaucracy and
You got to wait for the grid to take the charge, take the front of the line on that. Get in the front of the line and do something. The grid is already in the power companies, they're already in the seat to make something like that happen very quickly uh, with their own grid to eliminate the need for nuclear and to use their grid more wisely.
mm,
They have all
yeah.
those wires running all over the country, picking up solar radiation. It's the best solar panel you're going to ever build. All that copper wire and aluminum wire and all these conductors acting like a huge inductor over the planet and getting hit by solar radiation. What more do you need? They already built the world's largest free energy device, and it's called the grid.
Mm,
They
yeah.
just don't know how to wire it up correctly. So
Yeah.
they're giving it nuclear, they're giving it
Even
coal,
even
giving
Eric
it gasoline.
even Eric Dollard was talking
When all
about
they
that
need
in
is the
his
sun. The sun is
lectures.
giving can charge the grid during the day to run way past the night if you do it
Mm.
right.
Yeah, even Eric Dollard was talking about this, and he goes, you know what? Like
That's
the
right.
Steinmetz came up with this system, and he says it was actually a free running system because there was so much capacitance within the power grid itself. When you looped it back, it
Inductive
powered the
reactance.
generator. That's right, and that's what powered the Steinmetz generator.
You
It
know,
was
the, you know what's missing to the inductive reactive grid?
mm,
Capacitive reactance.
well, yeah, and that could be very easily implemented in the system. And if you had enough capacitance in a power grid system, you could have a fully looped power grid that goes right back to
Well,
the
first of all, the
generator.
grid doesn't have enough capacitance to create a resonance with the solar radiation, the solar capacitance, whatever that
Yeah,
is.
no, I'm just talking about the internal capacitance of all those power wires with power in them. You got some lines that are up to like 300,000 volts going through
Right,
it.
right.
It's very easy to tap off that and run a generator with it and just pump it right back into the system, a fully looped system. And
Right. If you
Dollard
had
was talking about
capacitors, you
this.
could do that. Right.
Yeah, Dollard was talking about this 20 years ago in one of his lectures. He said Steinmetz had this four-phase rotary generator, this
The
motor
grid could spin
generator.
itself
Yeah, it would spin itself. It had that amount of
with
capacitance
with
of
using the
power.
capacitors as the middleman to do it.
Well, back then they didn't have the capacitors in the system. It had enough wire out
Even
there that
today,
would
they don't.
charge.
I don't think they put capacitors in the grid today, do they, Mike?
No, maybe at the
So
substation. Maybe at the substation there might be, but
yeah, like what? Minimal,
yeah,
very, if
yeah.
anything at all.
Mm.
They got, yeah, the capacitors that the substations has are on their backup generators. Those run capacitors that run those motors. That's probably it.
Yeah, pretty much.
They need just about as much a capacitor array, just pretty much the same size as the inductive array that they have at the substations. And then any type of, radiation coming from the sun or anything else would get drawn right into the grid wiring and thrown right into that capacitor bank.
But even like a generator system that I have that runs on impulsive inductive capacitance, reactance, I should say, that would actually be, like a repeater station. You know what I mean?
Right. I mean, if the grid had enough capacitance, let's say the grid is using 10 kilojoules a second, and it had 10 kilojoules of capacitance, well, then it could, pretty much reuse those 10 kilojoules, almost all of those 10 kilojoules. Again, not
Yeah,
all of it, but almost all of
more than enough.
it. And it's, that's why they have to keep generating more power because they don't have enough capacitance to store the power that they're using for a second run.
Hmm. Very inefficient system.
And if you have enough capacitance, that second run could be a third run and a fourth run.
Hmm.
There is some, eventually it runs down, but the efficiency that we have now in the grid is, probably it could of its 100% potential, it's probably sitting at around about 15%.
Really that low?
And that's terrible, in my opinion.
Yeah, that is bad. That is bad.
And that's just a hypothetical guess. If I were to guess, the efficiency of the grid is around 15%.
Wow, it's not good at all. I didn't realize it was that bad.
So, all the other, 85% is wasted. And the 85% of energy we give the grid to keep it running is wasted, if that's the case.
Yeah, humanity's very good at waste.
Yeah, right. Because the three-phase alternator that Tesla designed was used to be a motor because people wanted a motor and everybody got their motor, right?
Hmm.
But but that thing guzzles energy. You get the same torque, same RPMs with a DC permanent magnet motor with 10, 90% less energy thing. So the three-phase the generator is not supposed to be a motor. It's supposed to be a generator. It'll produce a ton of energy, or it'll guzzle a bunch of energy. But if you want to rotate something with efficiency, you got to use a permanent magnet motor, and not an induction motor. An induction motor was never supposed to be. It was never supposed to be used like that.
Yeah.
The induction motor was never supposed to be an induction motor. It was supposed to be an induction generator. Because we got to charge those coils up with fields to get that
Yeah.
motor to spin. That's a total waste of energy. Those coils that are creating fields should be replaced with permanent magnets.
Mm. Yeah. When you're creating a field like that and you're fighting a magnet against a magnet, it's always a losing battle. So if you're
Yeah.
using electromagnets, it's even worse because you're using physical energy to do that.
If you're using electromagnets, it's okay as long as you have permanent magnets in the system to
Yeah.
instead of
Yeah.
because you don't want to have field coils, you know, driving another set of field coils.
Mhm.
with brushes, which is what I think Tesla did to make his AC three-phase generator to work as a motor for the public back in that day that was demanding a motor. Because there was no motor, there was no electric motor, was there? The first electric
There was
motor was
well, they had DC motors, but they were had a lot of arcing and stuff like that.
right, but DC is more efficient as a motor than an AC. AC is an efficient generator, not a motor. So if you were to generate power with DC, you're losing out. You want to generate power with AC to get all that efficiency. And if you want to spin a wheel, you do it with the DC, not AC. Well, your car alternator is like the Tesla induction motor, induction generator.
Mhm. Yeah, it's all induction. That's why you have to choose your cores very well, because if you have a core, as soon as you hit it with a field and it holds that power too long, actually works against you, creates the clogging, right?
Yeah. But plus, you got to energize that coil with a field to create that magnetic field, and that's also a waste of energy.
That's why the system that I'm doing makes it efficient.
That's where all the wasted energy goes. You're creating you're simulating a magnet with a coil
That's right.
to get that's a waste of energy. Tremendous
Well,
waste of it.
well, it is the
But they
world
don't
that
have a problem with that because then you pay more electric bill.
that's right.
So go
Yeah,
ahead and buy a three-phase motor and run it.
yeah. It's all about the money. That's what's driven this world, right? But I still love those Sterling engines. Something about
Stirling engine pushing a three-phase generator is
them.
perfect. You can't ask for more. With a nice flywheel on there.
Yeah, look, yeah, I think it could. If the guy had to make it work, enough people could come together. You could get drill rods to carve the flywheel. It makes me wonder what some of these big flywheels actually were in Chicago. Also, I mean,
Well, they work off in it.
they knew they needed them, and they had to come from somewhere.
What do you mean? What are you talking about? Flywheels in Chicago?
Some pictures show where the powerhouse was there. Well, there's giant flywheels, of course, to run everything,
Yeah.
supposedly.
Well, that keeps the
What,
But we
torque
don't
up in the
know
system.
because we don't
was
know
there
what was beneath there.
was
You
there a
know,
river nearby?
at Chicago World's Fair,
Is
I,
there a river near those flywheels?
yeah,
That's probably what it was.
they could have canaled anything.
Yeah, the flywheel is another ingenious.
I
I
might
wonder
have
how
to.
Yeah,
old when they first.
they built a station. I believe it's in Germany where they're using flywheels for energy storage. So they got these motors running these giant
Right.
flywheels, and then the other side's hooked up to a generator. And then when the power is needed, they engage the generator, and the inertia built up in that flywheel provides the current flow. And apparently they're working really, really good. They look like
You want to hear
cyborgs.
a really easy free not free energy but like a perpetual generator system with one solar panel, let's say a 50-watt solar panel and a pulse motor driving up a iron wheel from a train that's
Yep.
on a magnetic bearing
Mm,
with magnets on the face north and south for a stator, three-phase stator.
yep.
and you just use the 50-watt solar panel during the day to spin it up to top speed.
Yep.
So at nighttime, it's free power all
Yeah, you
night.
can draw off it. Yeah.
That train wheel weighs like 500 pounds or
Oh
1,000 pounds.
yeah. Oh yeah, they're heavy.
If you have
Solid
that on a
iron.
nice bearing, it'll spin very long time. And you can get it going up to top speed with just one electromagnet and a solar panel.
Well, in
It'll take a
1938,
few hours though.
well, in Switzerland in 1938, they had these buses running on flywheels.
Hey,
So every
is this thing shaking the house?
I
Is this
can
shaking
hear
your?
it good.
Oh, weird. I'm seeing weird effects happening.
Oh, you're getting into the oscillation of the house. You're gonna get
The
like
light
that
on
earthquake
my head is
machine.
shining in the fan in another room moving.
Is it? You're getting into the resonant frequency of the house.
I'm new at this. None of my stuff is set up, Mike. I apologize. It's it just got to be the perfect time though that I was at home.
Yeah, right on. I love your machine. It's awesome.
Do you, do you guys want to see the pulse therapy machine I got?
Sure, please.
I'm not gonna try to sell anything though. I mean,
No, I just want to see it. I want to see what you're working with.
well, let's see how fast we'll get this thing going. I've had it up to I've timed it at 1555. So I think it's like 900. We might be at 8. I'm
Still a
just getting,
pretty good RPM.
but it is fairly inefficient. But it has ran for 16 years.
Yeah, it's awesome.
I think I got an A on it.
That was a high
But
school project.
yeah, it was the project, and I was the oldest student. No one could get all the timing figured out.
Mm-hmm.
Oh, I want to make another one now. I want to do some more other stuff, like get involved maybe a little bit. I have a little workshop
Yeah.
because this needs to run something if we're going to do something like this.
Yeah, hook it up to a small motor and draw some power off it. Maybe charge
Yeah, I got a
batteries with
couple
it or
like that. I don't
capacitors.
chase it around now anymore,
A
really.
small DC motor, 12 volt, and hook it up to a capacitor and hook it up to a solar charge controller. Just make sure the voltage only goes to 12 volts. And then you can start charging car batteries.
And I want to learn how to get solar to work better for me when I could figure to put something and maybe have it do something. I think the girls would like a rock tumbler or something. If I could figure out how to get all that to run while we leave and then be running when we get back.
Mm-hmm. That's awesome. Yeah,
Yeah.
because I could run my Renegade off a solar panel no problem because it takes a quarter of a watt to run it. Actually, probably
See
even less.
the flywheel in your system there, machine head, is the capacitor. It's acting like the capacitor.
Yeah, it's inertia powered capacitor.
It's the storage device.
Do you think maybe the kid that engineered that, he said he wanted it's big for the system. He figured out to even engraving how deep to engrave the last part of the brass out of it to make it the weight. To
Right.
supposedly be a certain RPM, but if it ran at the heat too long, it would probably blow up. But in order to make power enough to turn one of those bigger flywheels, You always need a machine bigger, better, or smaller and more vague before the next better machine. So they need some torque, and then like if it was a capacitor somehow running for a short time with a lot of power, and then it got the bigger stationary engines running.
The capacitor keeps the flow going in the diaphragm when the temperature differential is not present. The capacitor will keep the flow going to bring in the new temperature differential from the outside. Or if it's from the outside, actually, I don't think so, but
The
it is from the
components
outside.
robust enough it would make it last.
The heat sink is the outside.
Yeah. That's all they're all hollow too, one piece. I suppose we tried welding some other ones.
What's the sorry to ask? What's the temperature you're heating that element up to before it actually starts to run? About
I
300.
if this is either 17.4 pH or 400 series stainless, I gotta have it at least. This torch could only maybe get 900. I don't know.
Yes.
You try to scale up the diaphragm on that. Make a bigger diaphragm, a bigger chamber, a bigger heat chamber, a bigger chamber.
Let's get it. Let's get it. I mean, at least 900. I got it pretty hot. It could work. It could probably fail. Some of these have failed, but mine is. I have another one that did.
If the chamber was big enough, you wouldn't have to heat it up at all. It would get the temperature from the room.
I think I've just tried to. I think that's its limit. I think it's only hitting at about 900, maybe 25 or so.
Yeah,
That
like
looks like brass.
yeah, it's probably brass or the flywheel's brass, right?
The whole thing, no? Brass and steel.
No, stainless steel for the heat chamber.
And a
How long did it
special.
take you to put that together, Machine Head?
It's stainless 304, right?
The core, the actual core is a 7,000 series aluminum.
Oh, okay.
In the air piston inside the chamber,
So you
Yeah,
wanted something lightweight.
and that's how
we
got tuned out of one piece. Well, it's two. It's got a gland in the front, but it's like the opposite.
Can you describe the diaphragm and the chamber and how that was put together?
Yeah, to make the internal part took a lot of horsepower too, drilling, like to drill it in one shot at one piece. So I imagine, things could be sealed together a little bit.
It's one piece diaphragm, one piece chamber.
Yeah, I would build it with a flat round spade, but a spade drill, so it has a flat bottom, all the outside and the inside. So
And there's a piston with a diaphragm disc
yep.
in that inside there, right?
So then that was all slip fit. So I think the wall's like 25,000. It's pretty thin, and that's where you can adjust. You get some differences, maybe without changing the whole size. We could have a heavier air one that I could get hotter. So I don't know if you guys can see where I have the torch at.
Yeah.
yeah, yeah.
The back of that
Heat sink
25
with it.
thin wall with the like 50,000 spot flat is getting torched every time.
Mm,
So I
pretty
worried about,
durable.
you know, longevity. Titanium maybe. Hard to machine that in one shot. But maybe there's something to the advent of aluminum and that we didn't have or that they needed or whatever. some change from the
Let's see.
world of carbon carbide to the aluminum titanium, and now it's the silicon dioxide or the CBN. Yeah, I think that's limited out. Oh, look.
It's a nice machine. Hey, it works, man. It works.
Yep. Let's see. That'll go, and I'll get this machine out.
When did you
You know
finish
what?
this build? Recently?
No, this is been running 16 years.
Oh, 16 years. Wow.
Yeah,
Yeah,
it was a high
That's
school
been
project.
running.
yeah.
That's been running for 16 years?
Not straight, but it runs and we run it. If you guys get to see it, the
Well, it
kids
It's
are
a
could
high
run.
school project.
It could run perpetually. I think you need it. The chamber needs to be like bigger,
yeah,
you know, so you don't have to heat it up at all. It'll pick up the ambient temperature by itself. And imagine that, because the inside of the chamber is insulated from the outside outside temperature. So when the
Well,
outside temperature changes, the inside temperature of the chamber will have to change also, but only through circulation of the wheel.
I heard some guys were building these things and they were using inert gases inside, either hydrogen or helium. They would fill the chamber up and it actually help make the system actually more efficient.
So
The
those
safer,
gases
the safe,
would they assist in the temperature differential needs?
yes, yeah,
Wow,
yeah, it helps. So
that's
helium's the
chemistry there.
safest. So helium is apparently the safest one to use for these engines.
uh,
So if you had helium in that
I
chamber,
guess helium does stay a little cooler than the outside air.
yeah,
That's smart.
I know the one from NASA. I believe they were using helium in the chamber. It was either helium or hydrogen, one or the other.
No, but what I'm saying is, if you didn't want to use helium, you could just make a chamber like the size of a water heater tank, like a 50-gallon water heater type of of chamber, and if the air inside the 50-gallon tank is colder than the air outside, it will turn the wheel.
Yep.
And that's the case right now with this chamber. The air inside that chamber is colder than the air outside, and that's why it's spinning. But the surface area is not enough of the chamber to capture enough temperature from the outside. So like a bigger heat sink, more heat sink on the chamber.
You could add a fan to it, get the temperature even lower.
Or if they engineered a metal that is good at capturing ambient heat,
Well, it's easier to
that
cool things off than to heat it up. So the cold side of the temperature differential, like the heat sink he's got there, if you add just a small computer fan, you could get that temperature down even lower. And if you get it lower, that means it's going to go faster without having to put any more energy into the system. So if you had a little motor, you hook it up to the flywheel to create some power, enough to make a little computer fan to run. Then you attach that computer fan onto the heat sink to cool the heat sink even more and create a bigger temperature differential.
that's also a good idea. I didn't think of that one.
Right?
That's a nice
Yeah,
one, Mike.
yeah. But that way you don't have to add more heat. So if you're cooling the one side down even more,
Right,
that
right.
ratio is now increased. Yep.
And there's also Peltiers.
Mm-hmm. Oh yeah, the Peltier device. Yeah, yeah, you can use that too. That would work.
Is it true that of a Peltier, you can get power out of it if just when it's
Yep,
hot?
yep.
I'm like,
It creates power. Yeah, I have one.
that's crazy. Well, you don't need a solar panel. You just put a bunch of Peltiers in series, I
Yeah.
guess.
Problem is they don't put out a
Stick
lot
them
of
out on the
power.
sun on a piece of iron, a black painted piece of
Like
iron.
they put out power, nothing spectacular. You would need about you would need about 20 or 30 of them to get any
You
significant amount of
suppose if you
power.
had like 50 Peltiers on
Hmm.
a square piece of steel about a half an inch thick, painted black, sitting out in the sun, you think that would outperform a solar panel for the same money?
Something you would have to test.
I think it would because the steel is the heat is like a flywheel kind of effect. It's storing
Well,
heat.
well, everybody has a black driveway outside. Just build a plate and sit it right on the driveway. You know how hot the driveway gets in the summer. You fry
I wonder what
onions.
those Peltiers are, how they operate, what the hell they're made out of. It's like I don't even know what
It's
those
a
things are made.
silicone.
How they're
It's a silicon semiconductor. So if you heat up one side, the other side cools off, and then vice versa.
silicon diode.
Yeah, silicon dioxide is what
The
you
dioxide.
do. Yeah,
So it acts like a diode somehow.
Mhm.
I
The
have
silicon.
right here gold magnet. I think it does something
Yeah.
for you.
I'm just gonna scoot. I'm just gonna
Guys,
scoot up for a
I
quick.
drove for a couple hours.
What is that?
It's a pulse electromagnetic frequency like therapy machine.
Oh,
I It has a red light too, but I don't have that right here. If the red light will go in there.
so what's in that handheld thing? A coreless
It's just
coil?
a
I'm just gonna
yeah, there's
scoot up for a quick smoke. I'll be right back.
magnetic coil and
So
in
it's coreless,
and
or it's got a
I
core?
can see
Yeah, I see
it's
it.
like
It's just got a few turns
I
with
probably
magnets around it, huh?
yeah. So we're just looking at seeing how's this thing working. So looking like is that all that right? More magnets.
What's the power supply to it? 12 volts? Low voltage? Because you don't have many turns on that coil, so you're not going to need a lot of voltage.
Yeah, there's a pretty good battery in there, that charges in the wall. So I could have these settings with say 5. It's just shown, like there's the pulse. Sometimes you could change all the setting, and then this thing maybe it'll make noise.
What year was that thing made?
Uh,
Is it a new modern thing, or is it like older thing?
repurposed maybe old technology or something they've developed in Liechtenstein. They use it
Liechtenstein.
uh horse therapy, human therapy, like
What's the frequencies on it? The output frequencies.
I think we're not gonna violate 7 hertz here with this thing.
So it
And I
doesn't
should
go
know
past
more about it.
7. It's not higher than 7 hertz. That's it. Huh?
No.
It's low frequency.
Yep. So I got it on my
Yeah.
and I'm gonna be able to do a workout here later before bed now.
Yeah, you can't. Yeah, low frequencies,
Almost. No,
harmless.
so there's a whole spiel that goes along with this whole thing. There's sleeping mats, there's programs, it can register this bar. You could set it up for the first 5 minutes, it'll be at one intensity and then another, and the pulse can go off and on. And
Put it. Did
There's
you ever put a
two.
magnet over it? Did you put a magnet over it? Do you feel anything?
Yeah.
The vibration? Yeah. 7
There's
pulses a second.
another phone down the floor. Oh, someone just came in. Mostly the other pads. Like there's a pad to go on the bed, and there's a pad to go on the bed, like to sleep, like it would fit on a lawn chair, nice. And it's gold, like pack it. Like I don't know if there's magnets in it, like kind of how they fold lithium batteries. Would they fold magnet gel in gold,
In
and then
gold?
and it powers through whatever this battery is in here, and that's therapy on a pad mat and a belt pad, and then this one's the like more intense spot, like it's like giving me direct pulses, magnetic pulse, like and if I had any inflammation in my elbow, I'm going to be able to grab
That's a
dumbbell.
so that coil with that 10-turn coil is what? That's a gold coil with folded around
The
a magnet.
things you saw, those were all gold. And then in the pads has even more elaborate setup of like a gold battery is what I think it is, like a gold magnet, like it grounds. I don't know.
If you got a schematic with it, you should take a picture of that.
I could get some info. I'm supposed to be like, I actually have a guy. He was
The
one of our
schematic will tell you everything.
at the machine shop, and they let him go for staying out too many times after COVID, non-COVID related absences.
If you ever see a schematic
Say
on any
that
of
at
those
work,
devices, I
'cause
would take a picture with your phone.
he sells them. He like he's distributes. He knows way more about it, and I know I could get more information. I tried to with Bernie, but I didn't want to get involved because uh competition. These things are $5,000. And
That's
this
not cheap.
one was a medical device, so it's like I don't know. I don't even know what we could see, but they got that to like travel to Canada. They saw a whole bunch of these in Calgary. I was gonna try to hook them up to see if they wanted to sell them, but it's like market level management. I don't know. I thought it as therapy, but I was really interested still in how this kind of gold battery kind of works. But I don't want to take one apart. But I wonder if the distributor does have some more schematics, or maybe if he has one that's taken apart.
I don't know how far you're going to get with the EMF field on a 10-turn coil. You got to probably put that close to the skin. Yeah?
Yeah, I mean, I'm probably good like
Depends
this.
on the amplitude too, of how much amps or how much power the thing uses, how many watts. You don't know. You got to look at it. Put a watt meter on it. You see how many watts it uses. Then you can tell by that how
It
much
has some
how the
stuff.
field is.
It has some like 1060 HPA to 700 HPA, 90% RH. I don't know all these terms. So it's 93% RH to 15% RH, whatever that is.
RH.
That could be some kind of safety thing for this part of the device. I wondered if the gold wire isn't gold. Like if I put this wire on the cat, it'll like it for about 2 minutes, and then it'll run off and be old. I just thought it was interesting, but because the marketing for it, they've got something to where it regulates how the hertz that
I think the Rife machine is the best idea. How it does the frequency sweep.
you get more with the Rife.
Well,
This
the Rife
is
does a frequency sweep. It goes up and down the frequency band.
this is like you're only gonna get what nothing more than a doctor would think you should do,
Right,
if it
right.
makes any sense.
If
Because
you do
doctors
But
the
are
Rife
not going to want
machine,
you to
that
get any.
thing, the Rife will do a frequency sweep and of the whole entire frequency spectrum within its range.
Yeah, I
So
think
believe,
goes really good with another amplifier, like a audio type of amplifier, and electroculture, like in your garden, like to keep away insects, to do help the garden grow, to do a bunch of stuff like that.
yeah,
What's
but
unregulated
you
frequencies, that it could increase maybe with the even with the electroculture if you had that right. I know I tried tubing, copper tubing, like quarter-inch tubing, and that worked way better than anything else.
what for the agriculture?
Yeah,
Well, here's the thing about copper that you
and to
don't
hook
know.
a ripe up with that, I bet it'd be way better.
Let me guess. Your plants were fruiting when you gave it copper.
Uh, they started, yes. They
They would
were
give
already,
out fruit. They would give out fruit, right?
yeah,
And you want to know why? Did
yeah.
did did your plants, some of them, did they fail after they fruited? Did they like die and get, weak and stuff after they fruited?
Uh, well, the pea plants did, but tomato plants
Oh,
didn't.
you know why? I'll
They
tell you
used,
why. I'll tell you why. You know what copper does? It's killing the plant. And when the plant knows it's about to die, what does it do? It produces seed.
uh, ooh. So it
So
knew,
copper is toxic to plants. It's what farmers use copper stakes to get their trees to fruit, and
yeah.
they know how to keep from killing the plant. They probably pull the copper stake out later, before the plant dies. But it's a way of tricking the plant to fruit. Hey, you're gonna die. You better have some offspring.
There were so many cherry tomatoes, we had to actually pull it. It was starting to
It's a
die, but
farmer's trick. It's a farmer's
I didn't
trick. The
want
copper
to
stake.
ruin the soil. There were so many cherry tomatoes that it was ruining the soil for next year.
Well,
I
it's
had
not the
to really
tomatoes. The
get them
tomatoes
out of
weren't ruining the soil. The copper was. Too much copper in
Well,
the soil.
no, just the plant, the tomato. Well, the next year you don't want that many seed. You don't want that many fruits to fall all over in the garden and be left there, because it'll be bad. But there were so many, we had to get it like out of there before it.
Yeah,
You
if you
know.
ever want to kill a tree, just or any plant, stick copper in there and leave it there. It'll take a while, but it'll die. But it'll fruit a bunch, and then it'll die because it's fruiting
So
because it's
we'll
being
do it.
poisoned.
We'll do it to plants that we want to be gone when we're done harvesting them.
What, the copper?
Yeah,
Oh, so
and
you know then.
probably
Okay.
don't go put copper by my like apple tree, or right away, or any of my small like stuff I want to keep deer from eating, because that's my main challenge.
Ah,
But yeah,
yeah,
that makes sense. So that makes sense. That's why there were so many. There was like 200, and the other one
yeah.
had.
When the
So
plant's gonna die, it's gonna fruit like crazy.
and
It'll
the thing
produce
about
seed.
the plant was, you just got to get that whole plant out of there. No, regardless, anyways, right? And it had so many cherry tomatoes. You know, we didn't want to have that in the soil for next year.
I'm a big tomato fan.
And we
Half
didn't eat them.
Italian, but
We
I got to
don't
tell you,
use
they're
them.
not that healthy to eat. Be careful.
No,
So
she won't use them hardly. So I got a bunch of them.
I believe they're high in
They
retinol.
do have more seeds too. So you're right. Maybe the lectin count went up.
Retinol and lectins.
So yeah, that was this. I don't. It's pretty dark here, I guess. Only got my little light. The Bamer group with their like medical equipment. That's the difference. So with the Rife, they inside there they have this, so it doesn't violate any of the like carry on requirements for devices. Who knows, you know? And then that just means it's so limited. It only has those couple settings. But for therapeutic reasons, like and sleep disorders and stuff, the magnetism, it puts your rhythm back. I guess that's what I find. It,
Guys, we're gonna square up here in about 5 minutes. So if there's anything you want to say
yeah,
or
just
show,
let me know, Mike. I haven't been on doing
yeah,
nothing. I'll try to get
yeah,
my other shop going when it warms up a little bit
yeah, we
more.
do show. We're doing shows regular every Friday night. So yeah, you
Uh,
can always join the conversation and join the other inventors that come on with us. So yeah, definitely come on again for sure. I like what
Nice
you're doing.
build there, Machine Head.
yeah, thanks. Well, I'll get start. I'll just do some stuff. Maybe you could help me get. I see you always have really nice like setups, even though they're just get screwed together in a certain order and you put the wires. I don't know a bunch of all that stuff. I know how to make all the fasteners though. I'm
Yeah,
just
it's
not quite up to speed on the whole electrical engineering
either was
side.
I. Either was
Or
I. I'm more of a machinist background than an electrical guy, but I've been dabbling with this stuff for over 20 years, so you learn over
yeah,
time,
you
right?
get stuff to work.
I'm a good troubleshooter.
It was nice meeting you.
Yeah, nice
You
to
got any
meet you for
electrical
sure.
issues, I can troubleshoot it.
It definitely opened my eyes up about that with the electroculture, though. I might not want to do that if I don't want a bunch of seeds or to ruin
Well,
the plant.
you change your wiring to the wire that they use for florist, the florist iron wire. You could use that. You won't get the same effects that you would with the copper. I know Gerard in Winnipeg. He does a lot of electroculture, so that's the go-to guy for that. He's been doing it for a while now. So
I mean, yeah, using coils to oscillate is probably good for the plants, but I don't know about the copper itself. Yeah.
yeah, he uses, I believe, iron wire. It's the stuff you
Oh,
use
iron
for the
wire.
field.
Yeah.
Yeah, yeah,
To oscillate the iron coil?
yep.
Or
Even
I,
putting even putting magnets in this around the plants. Just having the
Hmm.
electromagnetic field of a permanent magnet will actually enhance and make the plant grow faster. So, yep. Anyways, guys, we're going to square up here. Thanks again, Mike. Thanks again,
Logan,
Logan. Yeah. So, yeah, thanks a lot for joining the conversation and showing your heat engine and many other projects that will be coming down the road. Too bad Gerald didn't join us today. I guess he got a little busy with the family. But anyways, yeah, we'll do a show again next Friday night, probably about 9 or 9:30 p.m. Eastern. We'll be starting the show, so we're going to make it a regular day. And thanks a lot, everybody. Questions, comments, go visit Mike Does on his YouTube channel, my channel, Faraday Research. I got almost 400 videos now. So there's a lot of stuff, a lot of experiments. Adams motor. I did the Don Smith device. I did the N machine. I got everything there. So if you want to check it out, there's a lot of content there. And yeah, thanks a lot, everybody, for joining in.
See you.
Take care,
Have a good
guys.
weekend, Mike. See you, Machine Head.
Yeah,
Nice. Take care,
take care.
guys.